This is TWiT.
So we have a very interesting guest joining us for, as we often do, the beginning of the show. We like to do interviews. You may remember when DeepSeek kind of changed the world with its inexpensive model that was kind of using new technologies to create better LLMs using reinforcement learning. Well, there is a company called Reflection AI that has just raised $2 billion to challenge DeepSeek, founded by two former DeepMind researchers, and we've got one of them with us today. It's great to have Jeremy Berman here. He's a post-training researcher at Reflection AI. Jeremy, welcome.
Thank you. I'm not one of the founders.
Oh, you're not one of the founders. You're just a guy.
That's the next company he does.
That's the next one. Oh, that's
I'm
right.
Just someone they pulled in.
Okay, good. So tell us a little bit about what post-training research is.
Sure. Yeah. So I guess to start, we should talk about what pre-training research is.
Okay.
And so pre-training
yes. That makes sense. Yeah.
Yes. Basically what all language models that we used were doing maybe pre-2024, mid-2024. And the idea is we had this incredible breakthrough, which is we can stuff the entire internet into these deep neural networks. And we can basically, with the goal of the neural network mimicking the internet. So it's like a big internet document, right? So we train these deep neural networks to predict the next word that it sees on the internet. And eventually it gets really good at doing that. And you can imagine a system that's really good at predicting the next word in a sentence has to have some sort of imbued intelligence to be able to do that. And so pre-training is the process of stuffing basically the internet into a deep neural network and imbuing the intelligence of the internet into that network. Some consider it kind of like compressing the intelligence of the internet into a model. But the problem is these models are actually not useful. So you have a pre-trained model and it's just a document completer. So it just goes next word, next word, next word, as if it's just building a web page on the internet. So that's pre-training. And then post-training is the process of making that useful for humans and tasks. And so as an example, when you talk to ChatGPT, ChatGPT is a post-trained model in that it knows what a user is. It knows what an assistant is. It's trained to be helpful. These are not things that come out of the box. An out-of-the-box language model is just, it completes documents. And so post-training is then the process of turning that to be useful for certain tasks. And I would say post-training maybe from 2023 to 2024, 2025 was making it useful. So this is how you should respond. You should respond in this way. We can imbue a personality. And this is all by showing it examples of what we want.
And then in some respects, this is what differentiates Anthropic to OpenAI to Google is this post-training, right? Because essentially the models are all trained on roughly the same stuff.
That was actually my assumption before I really got into the weeds, and we're doing pre-training and post-training at Reflection. That is the prevailing wisdom. I think that's actually not true.
Oh, interesting.
The labs have actually quite different ways they pre-train their models. The general structure is the same, but the data they're training on, the mixtures of data they're training on is actually quite different. For example, some models include certain types of code snippets. Some models include certain types of data. As an example, I think Gemini has grown into the incredible model it is today because of an incredible pre-training effort at Google, which I believe is probably the strongest in the world right now. But yes, I think your general principle holds, which is post-training is where you give the model the personality,
right.
And it helps to have a very strong pre-trained model. But post-training is, yes, where Anthropic makes their models very good at coding, where OpenAI can make their models very good at reasoning. Yeah, these are things mostly done in post-training.
So as I understand it, we've talked a lot about this on the show. You have a corpus of information, Common Crawl, or a giant dump of pirated books, or the internet as a whole, and you tokenize it, and then there's some fine tuning that goes on in the after the tokenization, right? Even some reinforcement learning. Is that what you're talking about with post training, or is it even after that?
Is that still pre?
So I think actually the line is a bit blurry.
Okay.
It's really, and actually at Reflection, we called it training because a lot of post-training
post-pre,
has the
whatever,
same,
it's training. Yeah.
right. And I think maybe you can think about it like, what is the objective of the neural network that you're trying, or what is the objective that you're trying to teach the neural network? So in pre-training, that objective is predict the next token.
Right.
And there are certain if you want to train it to be a helpful assistant, you generally have a data set of helpful user assistant messages.
Right.
And then you can post-train it to predict the next token. But then there's a whole separate area, which is called reinforcement learning, which is fundamentally letting the model learn for itself, reinforcing, training the model on its own traces. And this is what DeepSeek R1 did. It brought this whole field into the next generation of actually having the model learn for itself. And so that is also bucketed in post-training. So I think generally the lines are a bit blurry, but it's helpful to think of what is the objective here. So the objective in pre-training and some of post-training is next token prediction, almost like memorizing the data set, imbuing the data set. And then there's another set, which is reinforcement learning or on-policy learning, which is I'm going to have this model generate a bunch of answers. I'm going to take the best ones, and then I'm going to feed it back into the training corpus until the model learns to basically build its own reasoning and thinking circuits. And you don't get typically that type of generalization and thinking for yourself when the objective is just predicting the next token. You really want the model to be generating thoughts on its own and then reinforcing on those good thoughts.
I want to take a step back here because your history is kind of interesting. You do have a master's in computer science, but you were an entrepreneur. You had 2 startups, part of Y Combinator's winter batch in 2019. And then said, I kind of like this research side of this. I want to get more into the AI research side. You read Jeff Hawkins' book. We've interviewed Jeff Hawkins. In fact, we got to get him on the show. He's a fascinating guy. He's the guy who came up with graffiti for Palm, and is a neuroscientist. And he's written some really interesting books about how humans think, how our brains work compared to how machine brains work. And according to our research, that's how that kind of inspired you to get into this research side on this. So you're relatively new to this.
Yes, I would say I've only been in this field for about a year and 2 months.
Wow.
Really,
a year and 2 months.
I mean, this is a new field, so it's not the end of the world, but that's interesting. Yeah.
Yeah. I had a startup. It's doing well. We have, we have an office.
Still around.
Still around. And I read Jeff's book, and I could just get a sense that if we are able to figure out artificial general intelligence, it will be the most important thing that we do.
So you're working on AGI more than anything else.
Yes.
This is your inspiration. And in fact,
yes.
The reason you're here is because you took on the ARC AGI challenge and achieved a remarkable goal, first place in 2024.
And then broke records again this year.
Yeah, 76%, 79%, 79.6%, which is remarkable.
Can you tell us a little bit about what the ARC AGI challenge is and what you did in these cases?
Yeah, so ARC AGI is like an IQ test for machines. And it's so simple that children can get 85 to 100% on the V1. But language models at the time, and this was 2024, late 2024, were getting like 4%, 5%. These were the best language models we had. And that was what really sparked my interest because, so what it is it's a puzzle. You have grids, input and output grids, and there's a common transformation rule that you can apply to the input grids to get to the output grids. Again, simple children's puzzles. And the key is, can you, given an input, generate the output grid? And children can do it. Everyone on this panel will get 100% on it. But the best language models in the world in 2024 were getting 4, 5, 6%. Totally not saturated. And
why do you think that is?
So the reason was they were pre-trained and then post-trained, but not reinforcement learned. And so these models are kind of, you can think of them like stochastic parrots, which is the objective of just predicting the next token, and that it's soaked up all of the knowledge of the internet and then on some post-training data sets, but it hasn't learned to fundamentally think for itself. And ARC AGI requires you to be able to think on your feet because you've never seen these challenges before. These are not on the internet. You can't hack this test. You have to be able to generate on-the-fly thinking. And this is a beautiful test. Francois Chollet created it in 2019, and it has really stood the test of time. But then
he's one of the founders of Zapier, by the way, and still
that's
runs.
Mike Knoop.
Oh, I'm sorry.
That's okay. He's the other
guy. Okay.
Yep. And
I'm taking, by the way, they have daily puzzles on the ARC website. I'm taking the test right now and not doing well. Let's see.
Yes.
Do you think that the LLMs also host a podcast while they do this as well?
Yeah, right. Exactly.
That looked like a V2 puzzle, which is harder, and I'll get to that.
Oh, you're just giving them an easy out. Don't do that.
Yeah.
But you're right. These are fairly simple. But these are not. By the way, one of the things, this is not verbal, and one of the things that the AIs, the LLMs we're used to, are very much about is verbal.
But it's important to note that these are nonverbal but easy. And so this goes to Francois's thesis, which I agreed with at the time, which is if language models are not trained on a thing, if it's out of their training distribution, they will not do well.
Right.
And this is the missing generality, right? Like humans are very good at on-the-fly thinking, learning new skills, learning a new board game, learning a new puzzle. Language models at the time were not, because they were trained to soak up information. They were not trained to think for themselves fundamentally. And this, so I was able to get top score in 2024 by basically generating a ton of Python programs. I had a language model generate a ton of Python programs, and then I would have basically a Python executor test those programs. And then the most promising programs would then be put in a revision loop where I would have a language model update, incrementally evolve the programs to be better and better. But what's important about that is it got first place. And then 2 weeks after that, O1 came out, OpenAI's O1 model, which is the first model which using the DeepSeek paradigm, which was taught via reinforcement learning to fundamentally think for itself. And it smoked my score. So I was first for 2 weeks, and then it totally smoked my score. And this totally lit a light bulb. I had a light bulb moment where I was like, this is really the new paradigm here. We have cracked the code for how to teach, basically to bring the general into distribution. And that is through reinforcement learning, through having the model try out different answers and then taking the best ones and then reinforcing on those and doing that in a loop.
So what sets Reflection AI apart?
So given this, the founders of Reflection were at DeepMind when DeepMind was really pushing forward the reinforcement learning paradigm. And the best example is AlphaGo. So AlphaGo is a program that via reinforcement learning. So first, actually, let's take AlphaGo V1. They took the best humans, they took games of the best humans, and then trained the model, pre-trained the model basically, to soak up the information from those games and then play Go. And this worked really well, and they got to human level performance. But what changed the game completely is that they said, you know what, screw the human data, let's teach these models to do it from scratch. And then we're going to reinforcement learn on their good ideas, have it basically self-play, explore the field, use no human traces, and see what happens. And this is what led to AlphaGo handily surpassing the best human. And what is often cited is move 37, which was a move
very famous.
That humans at the time thought was crazy, but turned out to be this brilliant move that no human had really thought of to play. And this is the power of actually letting the models think for themselves. And so at Reflection, we have language models that are general. We have this reinforcement learning paradigm, which we know produces superhuman intelligence. So why don't we combine them? And that is kind of the principle, I would say, that Reflection has been founded on, which is extreme expertise in AlphaGo style reinforcement learning plus expertise in expertise in language models. And that is kind of our origin story.
Jeremy, I read an interesting paper from a colleague at Stony Brook University 2 weeks ago that, I'll make this as quick as I can. They took given authors and they had writers summarize their work, and then they had AI summarize their work, and then they judged that against two pools of people, one who were expert and one who were just plain folk. And for the AI was fine for the plain folk, but the experts threw up their nose. Then they trained the models on the entire oeuvre of the authors. And then the AI summaries beat the human writer summaries with everybody, including the experts. And this really struck me. It struck me as a writer that I think that there's opportunities in publishing that we can't see in terms of creating, a Jeff bot. But it also struck me about the specialization of that. And so what I want to drill in a little bit is this notion of general intelligence and the effort at that versus what we know is the case is that AI can do specific tasks like AlphaGo really frigging well. And so I wonder, is seeking general a distraction from all kinds of new frontiers that could be met at a superhuman level, but not a general level? Did I make any sense?
Yes. This is currently, I would say, the question of the day, which is, are we building spiky superintelligences, right? Where we have this data set, it's clean, and we know for a fact, it's just a fact, that if you have a distribution of data, deep neural networks can learn that distribution and do it basically as good as we need it to, right? But the problem is, you can almost imagine it like it's overfit to that training data. So if then you give it data that it hasn't seen before that's sufficiently different, it will do less well. And so this is the spiky AI paradigm. And then the other paradigm is we figure out how to build generality, how to build basically the skill that builds other skills into these machines, and that you would probably see as both superhuman and superhuman at everything. And the latter is what I'm most interested in, but I think people at Reflection are mixed. People generally are mixed. It's not clear which one will win. I have a theory for why I think that we are going to be able to inject generality into these models, but it's not certain.
You may remember, Jeff, I referred you to a video which you never watched about how you can take an overfit model, reduce the parameters, and get it to actually generate an algorithm instead of trying to brute force the solution.
Leo, is this the 7-hour YouTube video you sent us?
This was a shorter one, but it was a very interesting theory. And if it's true, if you could have a AI generate an algorithm for solving as opposed to a simple, 2 + 2 = 4, then 2 + 3 = 5, have a truth table, that would be much closer to human actual intelligence. This is the kind of thing we're talking about, right?
Tell us about your theory.
What's fascinating is that there's a lot of room for innovation here, right? There's a lot of places you can improve the training, the post-training.
Yes, I agree. And I think at the end of the day, reasoning with sufficient creativity is the engine of generality. And I think right now what we're doing is we have these data sets that are very particular to a certain set. So we have a math data set and we can train it to be very good at math, and we can train it to be very good at reasoning in math. The problem is it's almost like the reasoning and math circuits that we've trained together are fused, in that then we ask it a question about something else and it generalizes a little bit, but not as much as we would hope it to. And I think this is what I'm most interested in, is figuring out why exactly that is happening. It's almost like when you ask a language model a task that it hasn't been trained on, it's like an adversarial attack because you're hitting weights that it's memorized in pre-training. This is actually what happens in ARC. You have these PhD level machines that are making obvious blunders on, again, questions that are very simple. And it's because it's hitting weights that were pre-trained. And when it hits these pre-trained weights, it has not learned to think for itself with these circuits. And so it ends up guessing it. This is where it hallucinates. It just goes down weird paths. And I think this is, there's one world where, okay, then let's just build a data set for literally everything. But then, when we have new data and the world is full of new data, right? Our brains are reasoning engines for a reason. Probably evolution knew that, right, we're always going to encounter new things. And so I think the right answer is we need to build the right environments and build the right training paradigm such that we, the models internalize reasoning for all domains in a general way.
I want to hear about the lunchroom. You said there's disagreement even within Reflection.
Yes.
I want to hear about those lunchroom conversations.
You want that, by the way. You don't want this kind of everybody saying, oh, yeah, we know how to do it.
That's a very theoretical level at which to express a disagreement. How does that discussion go?
Well, the people at Reflection are very smart. It's very fun. Lunches are very fun. We always have lunch together, and yeah, it's very fun. How did it go? Well, I think I'll toss out a few theories. They'll tell me why I'm wrong. I'll tell them why I think I'm right, and then we'll go from there. I think, it's fun. What is it? It's probably not. I think it's a lot of paper sharing and saying, "Look, I told you." This is okay. I mean, I think there's a really good paper. It's technical from Thinking Machines that just came out called "On Policy Distillation," which is what they did is basically they took a language model. They have a teacher model and a student model. And usually the way reinforcement learning works is you have the model try and, let's say, answer a math problem 100 times. You hope that one of those 100 is correct. And then you can take the reasoning that it used for that correct one and you can train it on its own thinking process. But that's very inefficient. And also, what if the model doesn't even get to the right answer, right? You've just wasted 100 traces. Well, on-policy distillation is a way for the teacher to actually, for each next token, for each next word, tell whether, I think this was a good next word, I think this was a bad next word. So you get a very dense signal. And so you don't have to do as many rollouts and the student model learns quicker. This is just something that came up in a lunch discussion recently, which I think is interesting because there's another debate, which is, do they even need to learn from their own traces, or is it okay that we have expert traces and they can just soak up the expert traces and they all of a sudden can kind of imbue the intelligence from the expert? I'm not in that camp. I think fundamentally we need to reinforce its own circuits, but that's kind of I would say that's a window into our lunch conversation.
So then when you want to say, I'm going to show you.
Hold on just a second. Yeah. We're talking to Jeremy Berman. He is a researcher and a very interesting person at Reflection AI, post-training research. And you don't win the ARC AGI benchmark, but you did very well. In fact, the new benchmark results come out in a few weeks. Do you know how you did yet?
Well, my model is currently at the top with 20 on ARC v1 79 and then ARC v2 almost 30. I think that's going to stand as the top score. Nice. But we will see.
We'll find out in a few weeks. I just want to point out.
You get a trophy?
You do get a trophy, and instead of a trophy, you get a lot of cash if you're able to get above a certain threshold. Let's say, I think it's something like 75 or 85% on ARC v2 under a certain budget, and it has to run on the Kaggle on the notebook.
That's
on a very
interesting
small amount of
too.
compute.
So you do this on Kaggle. That's interesting, and you have a budget for how much you can.
A $50
is it time or money
budget for 120 evaluation tasks.
By the way, I have failed miserably at V2.
You are a machine.
V2 is harder.
Well, my problem is I understand. So these are the examples, and this is then what you're supposed to do, and you're supposed to see what the transforms are, and it should be very easy. But this one is harder because the transform looks like it's a certain number of steps in color, and I just can't quite figure out. Maybe this wouldn't be good if you were colorblind. Let's put it that way. So. I've tried twice and failed twice. So
I also just one distinction is that I'm using models I'm using language models via their API.
Interesting.
And so there are two separate ways to do it. There's a way that you run your experiment on the Kaggle notebook, which is extremely small in compute. And then there's a way that I do it, which is to use an API for the models, for other models. And those are different. So I'm on the public leaderboard technically, and what I'm describing on Kaggle notebooks is called the private leaderboard, and they're the ones that are eligible for the prize. What I'm doing is not actually eligible for the prize, but I get $10,000 of compute per run, and my goal is really to just see where the frontier is. That's my biggest goal is just what are the best language models capable?
Yeah, you do this in Python.
Yes. The program's written in Python, but my ARC v2 solution, which I submitted before coming to Reflection, actually, instead of generating Python programs, I generate the programs in natural language. So they're actually just bullet points. And then I have sub-agents or sub-instances verify whether the plain English instructions actually work on the grids. So
that's cool.
It's basically taking advantage of the fact that thinking models exist now. They didn't when I was originally doing this. And so with thinking models, they're actually much better at reasoning on these types of things.
So you're vibe coding your solution in effect.
Yes, that's a good way to think about it.
I'm sorry, I didn't mean to interrupt you, Jeff. I just wanted to reintroduce Jeremy for people joining us.
No, that's
Go ahead.
good. So when you have that lunchtime discussion and you say, aha, no, I'm going to show you, you need compute to do that. I'm guessing that allocation of compute resources is the key to be able to try these things. What's the currency that you then work in, or does the company say, this is what we need to try next, and you're trying to convince the company that that's what the company should do, or are there 5 different experiments going on? How does innovation go on in a company like this?
So I guess I can speak at a high level. I can't talk about, I guess, the specifics. But I would actually, taking a step back, the goal of Reflection right now is to build the best or a frontier open weight model. And so our number one goal is actually to just make sure that we are doing the things that we know to work really well. Basically, excellence in execution. And so that's our number one goal. And it's, of course, great to do research, and we do research. And I think the research we're doing is really interesting. But our number one goal is making sure that we are able to produce a model that is really, really good and open weight.
So talk about the open weight part. That also separates you from some of the others. There's a mission there for our audience. Why don't you talk about that just a minute?
Yeah, so right now the frontier language models are closed, which means that if I wanted to run them, I have a business, I can't just download the model and then run it on my own computers. I have to send my request to OpenAI or Anthropic. And from a business use case, this is challenging for private workloads or for regulatory reasons. And so if I'm, a government, right, I want to use my own models on my own hardware, then I can't use frontier language models. And also there are various regulations or reasons why I wouldn't want to use Chinese models. And the Chinese models are currently overwhelmingly at the top, the best models in the world for open weight models. And again, open weight means you can download them. I can click a button, download them to my computer, and actually run them on my own computers. And so we've found this gap in the market where there are a lot of enterprises that really want to run their own models for various reasons, but they find themselves, if they do want to do this, they're using old models or they're using models that are not the frontier. So we're really going after that segment. And then there's a second proponent, which is just philosophical, which is it's really great to be able to contribute to the community, right? Like if we're able to build a great model, we can give it to researchers, and researchers will be able to run experiments. They'll be able to fine tune it for scientific discovery, for things that they are interested in. And so I think from a business perspective, it's interesting, but then also for just a research perspective, it's inspiring.
You say we will know we've achieved AGI when we can't create tasks that are easy for humans but hard for AI. Tasks like this ARC AGI puzzle, which turns out to be hard for a human too, but that's just me. But more importantly, I think, and I'm reading your Substack where you talk about how you solved this. Humans are able to extend reasoning from one discipline to another. We have consistent reasoning that transfers across domains. So an economist who's good at logic can become a programmer when they learn to code because it's a reasoning domain that's the same. It's not the same knowledge domain, but it's a reasoning domain. You say that this is something that AIs currently aren't good at. They have dead reasoning zones. They cannot cross disciplines that way. And is the training the solution to this? And also, have I misstated what you were saying?
I would say just generally it's for like OpenAI's models are very generally good, but that's because OpenAI has really great training processes and they have
they fill in the dead zones. They know where the dead zones and they fill them in. But we want to get a solution that that doesn't create dead zones, right?
I agree. And that is what I'm most interested in doing. And I think the way you can think about it is we pre-train these models, and knowledge from pre-training is stored like a knowledge web, right? Where there's not a cohesive or coherent causal relationship between things directly, in that you haven't tried out your ideas if you're a language model only pre-trained in the real world, right? You haven't gotten feedback on how your brain works. You've just been soaking up the information. So you have this, what I call a knowledge web, where you have semantic understandings of things, right? You can connect two things, but you are missing this causal understanding of the world because you just haven't tested your ideas out in the real world. And so I think what reinforcement learning does is it slowly shifts knowledge from this web to more of a cohesive knowledge tree. And I think the dead zones are places where we haven't yet merged or molded these weights to be coherent in the real world. And I think this might come from just a different training paradigm altogether, where we're able to maybe shrink pre-training, massively extend the scale of post-training, or some other ideas that I'm not exactly allowed to speak about right now.
Right. But that's what we're doing, right? We're trying stuff until we figure it out. But what's good is that we now have, it sounds like we have a goal. We have at least we're not sure if this is going to work, but we have a pretty good idea of what we want to accomplish. And now we can try different things to try to accomplish it.
Yes. And I think this is also why it's important that we have a lot of open weight models that are strong, because it's very useful to be able to get in there and actually try out your ideas.
Yeah. If you want to see what his English language solution looks like, Jeremy on his Substack has published a few examples. It's kind of amazing, really, that you can write a prompt like this to solve something like ARC AGI.
Yes. Yeah. It's models have gone a long way, and they will continue. They will never be worse than they are now.
Yeah. I think it's an exciting time. And what we don't know is whether we'll solve this, right? I mean, it's a terra incognita. We've not been here before.
Yes.
Do you feel fairly confident, though, that there is an answer, there's a solution out there, and that we can teach machines to reason?
I think I'm very confident that we will be able to build Spiky superintelligence. We have a data set. We can train the model to be extremely good at that data set. I think it's more likely than not that in the next 10 years, we have new ideas that will lead to true general reasoning. That
Spiky is not the solution. Spiky means that there's edge cases where it's just going to hallucinate. It's just not going to give you the good answer. You want it to be more continuous. You want,
Yes. And a good example is ARC v3, which is now actually a video game, and there are levels. And it's like an Atari game, but each level adds a new objective, a new twist. And the best language models, frontier language models, cannot do it at all. And it's fun. You can play a game yourself. Over time, you'll learn and you'll understand how it works. The best language models totally fail at this. And I think this is a good distillation of what I mean by we definitely do not have general intelligence. If language models are struggling to even pass the first level. I don't think a language model has even passed the first level of a real ARC.
Leo's struggling to pass the first level.
So Jan LeCun says that language models have kind of hit their apotheosis, and that he's one of those who looks at real world models and other things as the next paradigm. And then we had Karen Howe on her book about Empire of AI a few weeks ago, and she was talking about the controversy of those who think that scale is the answer and those who think that no, smarter training and different paradigms are the answer. Just in terms of just at a high level philosophical view, are you LLM side still, or got to do something new? Are you scale side still, or something else? Where do you see that future building?
I am more confident than not that language models will get us there. Mm-hmm. And I am also confident that as we continue to scale, the systems will be smarter and smarter. But I think it's important that we're not necessarily scaling in pre-training, but that it's post-training where we're scaling. I think, generally models that are bigger are better as long as they're trained appropriately. And but I'm actually not exactly sure if that's necessary. I think it's very possible that we will figure out reasoning and the models will be no bigger than they are today. Or maybe we'll figure it out and then the models will be able to build models that are much more efficient, that are the size that they are today. I don't think there's any physical reason why they can't be.
This is the problem, though, that I have with Jan LeCun and Karen Howe, and they're in different categories. But in general, with the speculation of, well, that's probably not going to work with that, we don't know. Right? This is what's exciting.
We don't know that it's going to work either.
We don't know it's going to work. We don't know it's not.
It's an investment risk.
But we got to try every avenue and have the smartest people like Jeremy thinking. I love the lunch. I would love to be in that lunchroom to get these smart people together, thinking about it and trying stuff. And until you got to try it all and see what works and see what doesn't work. We just don't know. So speculation from Jan LeCun that, LLMs have come to the end of it's speculative. We don't know.
Here's maybe I can steelman him, and I actually want to be careful because I'm sure I'm not going to do a good job. So maybe let me steelman an argument that I think does make sense for people that have that perspective, which is fundamentally neural networks learn the distribution they are trained on, which means you give it data and it will learn that distribution, but it will not be able to generalize outside of that distribution. So that is like Francois generally says this, right? Or maybe a variant of this. And this is true. But I actually don't think it's very hard to fit all of reasoning into that body. And all you have to do is fit reasoning into distribution, and that is it, because reasoning is the engine that builds all knowledge. You can deduce, from simple axioms, you can deduce almost everything. And so it doesn't need to be in distribution if it's deducible through coherent reasoning. And so if we have coherent reasoning and the ability to have creativity and taste on what to reason about, I don't see why it is the case that language models will not be able to discover new things. And discovering new things is, to me, the heart of general intelligence.
Love it.
So talking to us is probably like the question I'm about to ask. What's it like when you go and have Thanksgiving with the family? And they say, "What are you doing, Jeremy?" How detailed do you try to get?
You're still doing that little computer thing that you were doing?
Or maybe it's just like talking to us right now. I don't know.
It's probably very similar. Yeah.
No. What happens is, my mom is like, "You really need to clear your plate." And I'm like, "Mom, I'm working on AGI." Okay. Maybe someone maybe the lawyers can clean my plate. No,
You're doing so. I think I understand completely why you said, "I'm going to do this," because it is probably the most interesting and exciting and a thing that humans are doing right now. And yes, it may be a dead end. We don't know, but you got to try. And if you get there, well, you're not worried about we'll all be dead, are you? You're not.
No, I'm not.
You're not with what's his Eliezer Yudkowsky says, if we get there, we're all dead. Right. No. Okay, good. All right.
I think it's reasonable to assume that they will be around as dangerous as nuclear weapons. And that's
pretty dangerous. That's more dangerous than I would have thought. Okay.
Well, you're giving, if we are able to make these if we are able to do what I'm describing, right? Actually build general intelligence that runs in a reasonable efficiency. This means that everyone on the planet has basically an Einstein in their pocket, right? So obviously there's more to building a bomb than just Einstein's brain, but there's not much more to a lot of dangerous things. If you have, an army of Einsteins working for you for not so expensive, for maybe $100,000. So I think it's on the order of risk as nuclear weapons, but I don't think it is more than that.
Has the Reflection put any models up on Hugging Face or anywhere for us to play with, or these are all internal still?
No, they're internal, but we. I don't want to say any timeline.
It's a goal.
It's a goal. We will.
Yes. Reflection.ai building frontier open intelligence. Imagine going to lunch with the smartest people in the world.
There's some jobs open there, folks.
Yeah. How is it that we reason? What is it that we do? And you're right in the middle of the most exciting thing to happen in human life. It's great to have you, Jeremy. Thank you. Thank you for helping us.
Thanks, Jeremy.
Neanderthals understand what the Homo sapiens
Thanksgiving
are
Day
up to.
table. Yeah.
Yes.
Thank you very much for having me. And Mom, if you're watching, that was a joke.
He's gonna clear his plate.
Your plate, Jeremy.
I will clean,
and then we'll have you wash the dishes after.
Yes.
I don't know why I'm talking like that. Thank you, Jeremy Berman. Really appreciate it.
Reflection. She's here in the room.
I know because I'm a dad. I know. Thank you, Jeremy. Take care.
Thank you. See ya.
Hey, I hope you enjoyed this highlight from Intelligent Machines. We do the show every Wednesday. You can watch us do it live. Or, as they say, like and subscribe. There's a link down below. Thanks.